Okay, before we start multiplying and getting a precise answer, we just want a general idea of what our multiplication with decimals will give us. That helps us know if we're doing a good job later on. So our thinking before is to estimate the answer. And a good way of going is to think of that multiplication symbol as the word of. So I'm trying to calculate a fraction, less than 1, a fraction of 2. And that's why I can be pretty sure my answer is going to be less than 2. You can be even more precise than that and think about 0.4 as being smaller than a half. So our answer will be smaller than half of 2 or 1. That's up to you, but certainly have an idea of what your answer should be before you begin. Okay, into the algorithm now. When I'm multiplying with decimals, I'm going to ignore the decimals to start off with. So ignore decimals. Our algorithm can't cope with decimals. We just have to deal with them later on. So I'm just going to think about 4 and 2. 4 and 2. And I'm multiplying those and I would get 8. And after, so first I ignore the decimals, just treat it as I normally do. Then I have to compensate, I guess, for the fact that I ignored them earlier. And what we say is that the sum, or the total of decimal places in the two numbers you begin with, will tell you the decimal places in your answer. There is only one decimal place in both our numbers, just those tenths there, which means that my answer will just have one decimal place, and that's 0.8. Thinking after, if I want to see how I'm going, if I'm on track, first of all, I can compare my answer with what I started with. It is less than 2, and if you went that extra step, yes, it is less than 1. That's a good thing. So the answer is certainly a reasonable one. Now, if you want to really be sure, if you're not quite content with what you've done and you want to make sure you've done it well, or if a student wants to see a different way to do it, you can also think of 0.4 as 4/10. And you can think of 2 as a fraction of 2 over 1. And if I was to multiply those together, I would get 8 in my numerator and 10 in my denominator, or 0.8. And we always write our answer in the same form that it began. So if we started with decimals, we finish with decimals. And again, that's looking good because we got the same response each time. So thinking before, you should estimate. During, you ignore the decimals and compensate for them later. Count up the decimal places in both numbers that you started with and add it to your answer. And then at the end, to make sure your answer makes sense, and check it with fractions to be sure.